Good morning, welcome to the class for April 20th, hashtag 420. We are looking at square root graphs today. As you can see here, I've created a table of values for y equals the square root of x. As you can see, square root of 0 is 0, 1, 2, 3, 4. However, what I've got there is also the square root. I've got x equals minus 1. Does the graph of y equals square root of x exist Yep. Y equals square root of x. If you try and take the square root of minus 1, what will happen? Someone get their calculator out. What happens if you try and do the square root of minus 1? You should get an error. Yeah, math error. All right, so if we get the CAS calculator out, bring up the keyboard, square root minus 1, non-real IN calculator. Now, obviously, if you have your calculator set to CPLX, which those of you who do specialist maths would note you do get a different answer, but for us, we need to exist in what is real, not what is imaginary. So if you're doing anything on your CAS calculator using square root of x, you need to make sure that your graph is set to the real function. So, if we were to try and graph this, what would it look like? Now, obviously, I'm not going to have beautiful penmanship on this. And I try and roughly plot what these points might look like. So there's 0, 0, 1, 1, 4 is up here at 2, and then the others are like that. And the graph actually starts here and sort of curves. And then it will keep going and going and going. So remember that when you get to the square root of 9, so if this is 4, 9 is out here, it's only going to be about this high. Alright, the graph will go on forever. It's not linear, but it does sort of plateau, but it does keep going infinitely. Alright? And again, because we have an error, this graph does not exist beyond 0, 0. Alright, so this graph has what is called an endpoint. Alright, similar to how some graphs have asymptotes, this graph has what is called an endpoint. The endpoint there is where the graph just hard stops. It does not exist beyond that point. So, for example, this graph here, the endpoint is 0, 0. And what we can do is we can modify our graph by moving it left and right. All right, so we're going to go over to the CAS calculator and have a play with that. So, graph and table. Just clear out some of these other ones we don't need. And what we're going to do is we're going to go square root of x minus h plus k. Now what you'll notice is that I put the k on the outside of the square root bracket. The h is inside, the k is on the outside. All right, and if I use the variables to draw that graph, I have it set to 0. The graph exists there, so I'm just going to quickly move it over here so you guys can all see better, I hope. If I change the h value, similar to how when we move graphs, if we increase h, ooh, hang on, that's a bit different than normal, isn't it? What's happening here as I change h? What's happening to the end point of the graph? As I increase h, what is happening, or increasing or decreasing h, what is happening to the graph? So it's moving across the x-axis. And if I change k, it's going across, so it's moving up and down. So h moves it left and right, and k is moving up and down. But notice the graph does not exist. It does not exist beyond that endpoint. So in this case here, the endpoint would be 2, 3. Now, my question is, how could I possibly get my graph to exist facing a different direction? What could I possibly do to change my graph so that I could get it going another direction? Kareem shouts at the back, make the while thing negative. Whole thing. The whole thing negative. So if I go into my graph and I will now I'll make it negative square root x minus h plus k. So I put the negative in there. Let's see what happens. What have I created aside from a monstrosity? All right, so as I move, so now I've got both of these equations set up, they're mirror images. All right, so by putting the negative out the front, I've simply turned the graph upside down as I would for any other sort of equation. Now the problem is how do I get the graph to face the other way? So instead of starting here and going off like this, how do I possibly get the graph to turn around and go the other way? Alright, so how do I make the graph turn around and go the other way? Alright, and what I can do is I can actually put another negative symbol inside my recording. So inside my square root brackets. Alright, now if I go into here, minus so alright, if I make x negative, now the graph turns around and is going the other way, and then I can do the same thing again. I put a negative right at the front. And then, hey presto, all the graphs are working with the same thing. So these graphs are all of different forms, they all face in certain directions. Alright, and as long as your graphs are of this form, they will work. Now, what we can also do is we can put a number right at the front. And I can use the A value to stretch things. So if I edit the slider for A, we'll have it go 0.1. I can stretch the graph and make it thinner or wider as required. So I can stretch these graphs and make them thinner. Alright, so the questions you're going to be required to do for this class are 4C, so you'll need to draw the graphs and then decide what values of x and y do these graphs exist for. Alright, so I'm going to minimize this and then turn that off. And here we have our questions giving the axis-intercepts when they exist, the set of x values for which the rule is defined, and the y values for which the rule takes. Alright, so what they're looking for are the possible endpoints of the graph. Does the graph exist beyond the endpoints? If you find out where the endpoints are, you can easily say yes or no. Alright, so we're doing 4C. Make sure you send your work to me once you are done.